Hello again, psychology students. So by this point, we have already discussed in class about how to identify variables, experimental groups, control groups, and those types of things. This video is designed to help us understand more about those moles that pop up that we need to whack down to make sure that our studies have validity. And again, this is if you're ever designing your own study, as well as when you're reading other people's studies. It's important to know what sorts of variables can pop up and ruin experiments. As you know by now, confounding variables are any variable that can pop up and influence the dependent variable. If it's not the independent variable that you are intentionally manipulating and it influences the dependent variable, now you have a problem because you don't know which one is actually causing that change. And therefore, if you don't know which one is causing the change, we don't know what that experiment is really trying to tell us. So we're going to walk through the 5 major types of confounds that we can see in an experiment and talk about how to address them and keep them from ruining our data. So the first confound that we can start to see as we are creating a study is that we are dealing with people. In psychology, people are the focus of our study, but there's a difference between psychology and some of the other science courses, which is people are all different. And so when you have people that are completely different, there are a lot of different variables at play within each of these individuals. So we can start to identify things like the example we used in class of maybe you have a lot of people that have very fond childhood memories of Sesame Street. And then there's the random freaks like me who still get a little bit nervous around the count. So all of a sudden, that's something that you might not have known about. If you aren't, there's no way you can ask every question to identify every little thing in every individual person to be able to identify what those things are. But you know that each one of us has those little things in us that make us weird. And those little things that may not even be aware to anybody else, even those people that really know you well. But they could still influence the results of the experiment. So what we need to do is, since we can't measure every single tiny little difference between our people, and even if we could, when we broaden those results out beyond our individual study, those people are still having their own individual differences too. So we kind of go with what's our best option here. And the best option we do when we are conducting a study on people that are different is random assignment. And so I need to clarify, this is different from a random sample, and that's an often confused concept. Sample is how you decided who's going to be in the study. Now we know who's going to be in the study, so we need random assignment. And that is where we will randomly assign one person to the experimental group and one person to the control group. And every single person has an equal chance of being in either group. And so while that's not a perfect way to make sure that those weird things that we all have wind up in the different groups, what it does guarantee when we're running our statistical analysis of our results, what we know is that those people with those strange characteristics had an equal chance of being in either group. And what that really means to us is those people had an equal chance of influencing either group. So when we're calculating all of our data, there might be some differences among our participants. We know that. We know that's just something that happens when we're working with people. But what we also know is we're not going to worry about those as much, because we know that, yes, there could be individual differences in one group or the other, but they were randomly placed there. And so there's an equal chance that they're influencing either group, which is really the best thing we can do to be able to say, so we're not going to worry about that anymore because it might have messed with this data, it might have messed with this data. And ultimately, the more people we get in a study, the less influence a single oddball is going to have on that data. And so the real key here is when we're looking at how do we do this, it honestly doesn't matter as long as there's a clear-cut method that's going to guarantee an equal chance. You cannot, for example, choose the first people that show up to the study. Because if we say the first half are going to go to the experimental group, well, there could be a difference between the people that always show up early and the people that always show up late. So we need to wait until everybody's there, then split them off with an equal chance of ending up in either group. You can't let people choose based on personal preferences because, again, personal preferences can become a variable. And so what we're hoping is those random little strange things that we have will equally influence both groups and kind of cancel each other out. And they definitely will the more participants we have as we keep going through time. So that's how we whack that mole. We randomly assign, and that way we know at least we're not letting a variable get in the way through that process. So then our next confound that shows up is the expectations of the people in the study. And that completely changes results. People, when they sign up to be in a study, they know they're in a study. And when they know they're in a study, people very often will try to do what the experimenter wants. And so if you know what the experiment wants, especially if you know this experimenter has probably put a lot of his career into these studies that they're conducting. So people like to make other people happy. And so therefore, they will change what's happening. And sometimes it's consciously, sometimes it's unconsciously, to be able to please the participant and follow along with expectations. One real strong example of this is the placebo effect. So if you're not familiar with the placebo effect, it is basically this concept that for a lot of physical symptoms, the act of taking a pill that you think will make you better makes you better. So if we, and you can see the example on here, depression is one of those illnesses where if people take a drug and they're told it's an antidepressant, a lot of people will start to have fewer symptoms of depression. Other common traits like this would be like pain. If you are given a pill and they say this will help with your pain, it helps with your pain. And the interesting thing about this is it doesn't matter if there's a drug in there or not. We can give them a sugar pill or a pill that literally just has water inside of it. But the act of taking the pill makes you expect to feel better. And so then you do start to rate yourself as feeling better. So what we need to do in order to control for this expectation is create a single blind study. And so in a single blind study, we basically mean that the participants in the study don't know whether they are in the experimental group or control group. And then we can compare them against each other. So if we are running a study on antidepressants, we know we have to give both the experimental group and the control group have to receive a pill, because we know that both of them on the act of taking the pill will start to feel better. So what we need to prove if we are actually trying to market an antidepressant is if everyone's going to increase by a certain percent, we need to make sure that the experimental group increases more than the control group. So the only way to make sure that's happening for sure is so you don't know which one you are taking. This can also be a factor in things like food preferences. There have been other studies where if we give you 2 bowls of cereal and you see one of them being poured out of the name brand and one of them being poured out from a generic one that just says like OO cereal versus name brand Cheerios, and we ask you to taste them, you're going to say, I like the name brand Cheerios better. What studies have found though is if you just flip the cereal that's in the box, even if you put the off-brand cereal in the Cheerios box, they're still going to prefer the one that comes out of the Cheerios box. So again, that expectation of participants. So the only thing you can do in a study like that is say, here's cereal X, here's cereal Y, which one do you like better? And then you're getting an actual single blind taste test where you can expect that the results are due to the actual experience of the participants rather than their expectations. So again, that's a single blind study. But that leads us into the Confound 3. Sometimes the experimenter also influences the study. And we do need to go off the assumption here that this is not fraud. The experimenter is not trying to manipulate the data. That becomes a whole nother problem. This is going off the assumption that we have a genuine person running an experiment who genuinely wants to see the best data, but they also designed the experiment. And usually they have something riding on the success of this experiment, whether it's an increase in their professional status, it can be actual money, it can be funding for future research they want to do. And so experimenters have this bias already. They're expecting the results to be a certain way, and they want the results to go a certain way. And so it's really important that when we can control this, we control this too. We do this through conducting a double blind study. So double blind now, we still have the single blind in play. The participants still don't know who is in the experimental group and who is in the control group. But now the experimenter doesn't know either. And so the experimenter is running all the data, they're interacting with participants, and they don't know who the participants, they don't know which group the participants are in. So this is where you can start to add a lot of, this is where we want to avoid things like let's go back to that antidepressant study again. If I go in as an experimenter and I know that the first candidate that I talk to has been taking the drug that I've been working on for the past 10 years, I want them to feel better. Because if they feel better, that means my drug is working. So when I go in there, if I know they're taking my drug, I'm going to start acting differently towards them. I might not even mean it, but I'm going to go in, I'm going to be more friendly. I'm going to be more encouraging. And even if I'm working with a script that's saying the exact same things, I can deliver those lines differently, even unintentionally. So if they start coming in and saying how they're not feeling any better, I'm going to feel some negativity there because my drug isn't working. Or if they're feeling a whole lot better, I'm going to be showing some excitement there. And it's not on purpose, it's because I'm very invested in this study. And on the same roll, if I go into that control group and I'm not expecting them to feel significantly better, and they are, now that's starting to undermine the results I could be seeing too. And so that's going to dictate the way I now respond to them also. And so the way we control for this, as we said, is the double blind study, where the experimenter is going in, and if they're interacting with these participants or even just studying the data, they don't know. They don't know if the person they're talking to is in the experimental group or the control group. So if that person says, I'm feeling a whole lot better today, I can't respond because I don't know if that is actually good for me or bad for me at this point. People often ask, okay, so how does anybody keep anything straight? Researchers always have assistants. So if I go in and I say, all right, I'm going to go in and talk to this person, there's an assistant who is aware that person A is in the control group, person B is in the experimental group. I, as the experimenter, just don't know what that is, and they keep me blind for that data until it's all said and done, and then we are analyzing data and saying, okay, look, this person was receiving it, this person was not. So there's other experiments we're going to talk about with this also, where that expectation of the experimenter really influences things. The other quick one we'll address here is a study where offered rats to students and basically said, we have, some of you have some smart rats and some of you have some dumb rats. And what we want by the end of the study, we're going to see how that works out in terms of who runs this maze more effectively, who runs it faster with fewer errors, and those types of like how well they learn in these mazes. And what the participants did not know is all the rats were randomly assigned. Maybe your rat was smart, maybe it was dumb, but what they did find was the people that expected their rat to be smart handled their rat more often. They interacted with it differently than the ones who believed their rat was dumb. And it turns out that the smart rats, which again were randomly assigned, ended up being more successful in those later tests, not because the rats were any different, but because they were treated differently. And we have seen a lot of other studies that follow that same trend, where if the experimenter expects something, there are a lot of unconscious actions they can take to keep that from happening. So again, we use the double-blind study to control for that. So this next confound is relatively straightforward. There is always that environmental condition that might influence results. And honestly, the solution here is just control them, because it's not something that we can always like say an absolute rule for. If I am putting my experimental group in a super hot room and the control group in a super cold room, they're feeling different, they're interpreting their experiences differently, and therefore I don't know if that's influencing my data. If we're running a driving test and one group goes in the morning and one group goes in the afternoon, well, maybe the sun's in the eyes of one group and not the other group, which could also influence those results. So the bottom line here is look at what environmental variables could be and make sure that they are the same between both groups. And the last one we have, where unfortunately we see the mole hitting us back on this one, is we can't predict every confound. We try, and we've told you from the beginning, we're playing a big game of whack-a-mole. We want to see that confound, we want to hit it so we don't have to worry about it anymore. But sometimes it just pops up and we didn't even see it coming. And so again, we work as hard as we can. We predict our confounds, but sometimes we miss them. And so one of the classic examples of this was a study from, I don't have years in front of me. It was a while back. And it created what we now call the Hawthorne effect, where they wanted to go and see if lighting conditions improve productivity in a factory. And so the picture on the bottom right is, of course, of that factory. And as they went in and started setting one group for low light, one group for high light, and seeing what happens to productivity, they found everyone got more productive. Well, how does that work? And what they figured out is it was not the lighting that caused these people to get more productive. It was the fact that they were being watched. And so when they knew they were being watched, they became more productive. And that led down a whole new path of research, which we now call the Hawthorne effect, that just being observed changes behavior. The awareness of being observed changes your behavior. So that becomes a whole new direction of research, but it messed up that data. And there's example after example throughout scientific research where there's just that new confound that came in and messed up data, and the researcher just didn't see it coming. So those are our big 5 confound problems and how to control them as best as we can. Of course, some of them are real easy to control. Some of them are a lot more difficulty. There are a couple other components when we talk about experiments. We know the big draw of having an experiment is that we can infer cause. We can have some data that directly tells us this thing causes something else. One of the concerns there becomes generalizability. As in, does this data generalize into the real world? We have to put so many controls to be able to say this variable changes this variable, that sometimes we over control to the point that we question, is it even possible to say that this is going to happen in the real world? Sometimes there are also ethical considerations that keep us from having a true experiment. So, for example, if we know that one of the variables could result in an injury to one of our participants, we can't run that study. So sometimes we have to do what we call quasi-experimental designs. And so if we have something like, if you are texting while driving, we think that will cause more severe accidents. Or we see real life data on drinking while driving causes more accidents. We make those statements, but we can't run a true experiment because we are basically saying, I think my independent variable causes people to get hurt. So we can't run that study. So sometimes we have quasi-experimental designs, and the quasi-experimental design is there to show us that there seems to be some causal relationships between these variables, but we can't run the full study. What we can do is take the data that we do have. So we do know that texting and driving are very strongly correlated. So let's start to identify some of those patterns and see if we can identify a cause. So there are plenty of examples like this that we'll be exploring later on through this course also. The last piece I wanted to address in this video is research ethics. So we just said sometimes we can't do experiments because of that. So let's address kind of what's going on here. So any study that is supervised by the American Psychological Association needs to follow certain ethical guidelines. As we will see right off the bat in our next unit, there used to be kind of the Wild West when it comes to what are we going to do? What could the impacts be on the people? And there were enough concerning studies that there are now guidelines that protect participants in a psychological research study. So these are all influenced by an institutional review board. And just like it sounds, this is a board of people at a certain institution that reviews every single study that will influence other people. And so it doesn't matter if you think it's going to hurt people, if you think it's going to be good, they still have to approve it as that extra set of eyes on your work to guarantee that every participant will be protected. So this is completely independent of the research. It is just created by any institution that conducts research. And just to show you how seriously this takes it, I had a project for my master's degree where I had to interview someone that I thought was a global citizen. Now, since that involved conducting research with someone that was not a member of the university, I had to propose this study to the institutional review board. So they needed to see every question I intended on asking. They were asking questions like, well, what harm could this bring to this person? What sort of stress or discomfort could they experience? And so I'm sitting here, well, I'm talking to a friend who lives in Korea, so they're going to have to get up really early in the morning to talk to me. And so then the institutional review board has to go and weigh the pros and the cons of the study and be able to determine if this is an okay study or not. And of course, in that one it was, because they consented. They knew that no one was required to do this. But it's just that watchdog to make sure everybody is doing what they're supposed to do. So ethics has a few bottom lines here. And basically, the overarching concept is participant well-being always comes first, no matter what. But there are some key terms you need to know when we talk about ethics. Some of these are really like explicitly stated in some of the readings you've been assigned. Some of them are not, but I consider this like a master list of ethical guidelines. Of course, looking at how we are protecting the well-beings of participants. This does include their physical, their emotional, and their mental well-being. So informed consent is just what it sounds like. You are agreeing to be in the study, and you have been informed on what the study is. So you have enough information about the study to know what you're getting into. And we can't deceive any more than we have to, and we'll deal with that at the end here also. But this means if we think you might get stressed during the study, we have to tell you that. You have to agree, yeah, I'll do this study, even though you think it might stress me out. Confidentiality is that each participant's identity is kept confidential. So if you participate in a study at any point in the future, your name will never be included unless you specifically give a different consent to do so. Otherwise, they might say this participant or a participant engaged in this behavior, But for the most part, your data is just going to be lumped with everybody else, and no one will know that you as an individual were involved in that study. Of course, as we have already mentioned, protection from physical and mental harm in all cases. If there's any suspicion that you will be harmed, the study just can't happen. If we begin a study and we see that harm is happening, the study needs to get shut down. And so we'll talk about one of the famous studies that was supposed to go on for 2 weeks and only lasted 6 days because of the harm that started to happen to participants. So again, ethical guidelines require we must shut that down to protect from any more harm happening. We also require voluntary participation, which just means that you are a volunteer. You have chosen to participate, and we cannot coerce you to start the study or stay in the study. And so even if you are given an incentive, if you're in a paid study, they can't coerce you to stay by changing that pay. If you begin the study, you sign the informed consent, they have to carry through on that side of you agreed to participate. And now if you don't want to, you can leave and still receive those incentives. And the last thing we have here is sometimes we need to lie in order to not make knowledge be the variable. And so if deception is involved, it becomes mandatory to debrief after the study. So there was a study done where they wanted to see if you're in a room with other people and smoke starts to enter the room, how fast do you leave? And what's the difference in the study between having people in the room with you versus being by yourself? How fast will you leave, and will you leave? And so the study actually involves sitting in a room. You believe the study was going to be starting shortly, and they start pumping smoke into the room. And when they start pumping smoke into the room, the dependent variable is how long it takes you to leave. So in that point, they had to lie. Because if I go in and say, oh yeah, I'm just going to see how long it takes you to leave the room when I pump some smoke in, then that completely undermines the study. So when any deception is involved, you have to immediately take that moment when they walk out of the room and say, all right, so thank you for participating in my study. Here's what I was actually studying. And go through what were the variables you were studying. They will get access to that research when it's complete. If there's anything where they're stressed, they're going to make sure that you are in a good state of mind before you leave. And sometimes that even means that they might follow up with you later to make sure that we didn't cause any harm or any mental distress on the part of the participant. So that closes us out on our ethics. So what we should have had here was you should now be able to identify what are the big 5 confounds that we can see interfering in our variables for experimental research. You should be able to know how to address those, especially the ones that we have a clear method on how to address them. And you should be able to identify ethical procedures when going through and creating a study, and the things that are expected of the researcher if you ever participate in a study. As always, if you have any questions or concerns or suggestions, please reach out to me. You all know how to get a hold of me, and I'm happy to help and make sure that we have the best understanding we can so you all can be your most successful. So thank you again. I will see you all soon.